So another thing, another part is engineering documentation is part drawings. As I told you, for each part we need a drawing, only single part drawing. Okay, so in the assembly drawings there are many parts. In the assembly drawings there are many parts. Okay, so here many parts shown together. But in here, in assembly breakdown, also many parts shown separately together, but as a breakdown. But in here, only one part. One part is shown with dimensions. Okay, so many in assembly drawing, many parts are shown together. In assembly breakdown, also many parts, but shown in 3D. Okay, shown in 3D kind of thing, three-dimensional view, kind of isometric view, isometric view. But this one can be shown as a front view. We call 3 view. Okay, 3 view or orthographic view. Orthographic view. And in the part drawing, how it looks like. Let me show you how it looks like. Yes, similar to this. So, for example, the hook shape is shown, and from the front, and that is from the side, from the left-hand side, and only the one part is shown in this drawing. That calls like part drawing. It has all dimensions that possible to have with this or to produce this part. Okay, so by using these dimensions, we have to be able to produce this part. And nodes, so some nodes can be done in here about the tolerances or about the dimensions or about the surface of chemical treatment of the surface. Okay, so painting, so it should be painted in order to reduce kind of corrosion. So kind of things can be written in some empty place. Okay, so an empty place, we call those one nodes. Okay, so we will study about the nodes also in different lecture. The nodes somewhere here or somewhere here. Okay, and tolerances. Tolerance means in the drawing, in the dimensions, you can, if you see plus and minus signs, okay, plus and minus 1, plus and minus 0.5, those are tolerances. Okay, so we cannot produce 106 diameter. Okay, so 106 dimension exactly. So so we have kind of limitation. Okay, so it might be different size than 106. Okay, so 106. So how far? In the plus sign, 0.5, and to the minus side, 0.5. That means 106.5 or 105.5. That is 106.5. About this also we have different lecture. Okay, so all those information will be included in the part drawing. So So another thing, part drawings for buying. Okay, specification of the features and characteristics of purchased part. Part drawings for fabrication and for buying will vary. Okay, so two part drawings are different. That one is for engineers. Okay, so for fabrication. That part drawing for who is buying the product will be different. Okay, so by the using of this part drawing, so you can maintain, you can see what's the features and what's the characteristics of purchased part. Another thing is part list. Part list, as I told you, you will have a list of parts. What kind of parts are included into the assembly, and what's the numbers of that parts drawing. Okay, so and then by this numbers you can find it. You can find so number of drawing will be here or here. Okay, so by the numbering of the part name and number, you can find single parts drawing, and then see how it looks like and what's the dimensions and how to produce it, the sizes for producing. Bill of materials. Bill of material is similar to the part list, but that will have a database. Okay, so that you can find from the database that is in the computer. Okay, so bill of material normally we are using. Okay, so part list in the drawings can find in the drawings part list. Same thing, bill of materials are same thing, but you can find this one in a database. Okay, so database DB or database database. Okay, that is in the computer. You'll find. So that will be kind of a table and kind of a chart. Okay, so table. So one single database might be 100% accurate and allows the accurate determination of the cost of each specific product. Normally it includes the cost of the part. So then if you produce kind of bill of material, so every part name and then how much it costs, so you can get the cost of the product. Okay, so that is needed for manufacturing purpose of. Okay, so how it looks like. Okay, so similar to this one. So it has part of the component, some the prefix like assembly drawing number, part list number, specification notes, you know, with dashes like in the prefix here. That will be the part of component number of some components. So dash and some number. Okay, so the smaller numbers, smaller inside inner component. Look, okay, so bill of material, it has like part number, description. Okay, so part number, description, what's this. Okay, so part number one, that is a 110, part number 110 is the name of that part is steel pipes. And who is working with that one? Who did this? Who produced this or who designed this one? So engineer Ryan did that part. And quantity, we don't know how many, not answer. Okay, so for example, this one quantity. So item is a part or assembly, just part. the size, A size, B size, C size. So it's depend on the company rules. Okay, so whatever you can do, the size components like size, sizing, you can do yourself. Some description. Okay, so and weight of each one. So unit of measure, unit of measure. So and it might be kind of millimeter unit or inch one, inch based one, imperial. Used on 100, used on somewhere, used on the product number 100, used on product number 150. So it's up to you. Okay, so your own description of the numbers. So it will including size, weight, unit of measure, and used on where, in which product. So those kind of table in the computer, in the database, it might be needed to create a bill of material. Another thing, we need the technology manual. So we already did a design, right? So how it looks like and how it looks like in assembly view, but we don't know how to assemble in the manufacturing point of view, how to bring all together. Okay, so how to bring all together. But here we can see the concept. Here we have a concept design, right? So so outer shape of the phone, interior shape of the car, and inner shape interior of the room. So in patent we have, and also the outer surface we have, and so assembled shape we have. But how to do this? How to assemble? First one, which should be inserted and inserted of the body, and which one should be next, which one should be third one, which one should be fourth one to be inserted correctly. So if you do not have that ordering, so you might assemble wrongly. Okay, so for example, engine, if you assemble the engine, you have to follow the rules. Otherwise, first one, which one is putting first, and second one, which one is putting secondly, third one, fourth one. Okay, so if you do not follow that rule, so you will assemble wrongly, so your engine will not work. So that's why the technique that we call technology of assembling should be done. Okay, so in order to produce this thing, and so that's why is a technology manual is important. How it looks like. How it looks like. Technology manual is a list of sequences of operations. Okay, so for the machining, riveting, countersinking, preparation for assembly, etc. Okay, so manufacturing process. So we will have different lecture for this one. Okay, so next lecture will be about this. The recommendations for operators. Okay, so do this one and bring that tool and use that tool. Okay, with this mode. Okay, so recommendations for tool using and safety rules. Okay, so I will show the technology manual, how it looks like. So this one is technology manual, so manufacturing instruction technology manual for to make a hand drilling, reaming, and countersinking techniques. Okay, so it's kind of technology manual used in Airbus company, so aircraft producing company. So it has a lot of pages, so and you can read through it all. And for example, like key identification you can find from here. So set up the tools like that. So you can use for this whole size, you can use RPM, this one, so rotation per minute, so tool, and the pistols, appropriate speed pistol, bring this one. For this items, okay, so for this whole size, I really use this RPM and speed of the pistols like that. Okay, so minimum and maximums. And for example, I will show you another picture, kind of recommendations. Okay, so so coolant must be applied during every cutting operation. Kind of cooling thing should be applied before doing cutting. Okay, so every cutting of hole. For example, they need to use this kind of tool, for opening a hole. Okay, so they're putting here and drilling by using this device. Okay, so in order to make the holes correctly. Okay, so so inspection of first hole and every fourth hole, not every holes. Okay, so first hole and every fourth hole. After 3 holes, the check fourth one. When you are after completing everything, just inspect it, check it. So go, no go tools. Okay, is using. Okay, so these kind of recommendations, documentation calls like instruction or technology manual. So those are technology manual. So another thing is customer service manual. So maintenance manual or customer service manual. Then normally when you buy some home appliances like a television, TV set, like or fridge, so you will find inside that kind of manuals, the service manual, okay, or maintenance manual. So it consists from ways to repair or disassemble, replacing a new part, or reassemble, or how to clean it out correctly. So recommendations on correct using and servicing locations. If you cannot do yourself, yes, you can call the service location, some servicing place, and then they're helping to you in order to repairing it. Okay, and so you can find it in everywhere. So I have one example. So here you can see the service manual of fridge, refrigerator. So you can see a lot of drawings are there and explanation about that drawing. Okay, so the items, part names, and explanation in many languages, even though. So it might be in 5, 10 languages. And at the end of the manual, you may find the rules, what's correct, what's not, the attentions, and the addresses. Okay, so the place for maintenance for this is safety manual, and it has performance of design against every requirement. So verification. Okay, so features, performance, and safety, like personal impact, electrical shock, and some electrocution problems. So or fire hazards kind of thing. Hazardous kind of thing should be included inside safety manual. Okay, so how it looks like. So safety manual also normally included in home appliances, and if you work in the office, it will be seen in near to the door or outside of the door in the wall or nearby somewhere. Okay, so the engineers they normally should prepare this kind of manuals for their product. For example, you are producing a car, so you need to produce documentation about the safety also, and then provide that manuals to the clients. Okay, so customers. So for example, here you can see 2 types of manuals. The left hand side you can see the lab safety rules. So it's kind of poster. It's kind of a big poster. Okay, so in the big paper. So that is normally is inserted. Okay, installed in the nearby the door of the laboratory. Okay, so for example here, dress appropriately the glues and glasses, and if something happens in emergency, for the emergency, for the first aid, just call 911. For example, that kind of things calls like safety manuals. Okay, so for example, the manual handling, do's and don'ts at workplace, manual handle or carrying of loads in the workplace. So for the lifting, if that exceeds from 30 kg, 30 kg, use kind of something like, you know, tool for moving it. Okay, so turning. So ensure there is enough room, big place to turn around to prevent twisting your skeleton. Okay, so don't turn if you have no place, or use platform like this kind of elevating platforms when you are moving the things on the staircase. Okay, so the if heavy weight on the staircase should be used with using a elevating platform. So similar, this kind of rules and graphically might be shown for the purpose of providing safety. Okay, so okay, so another thing we have to see is the lettering principles. So we are drawing in types of the sheets, like from A0, A1, A2, A3, and A4, right? So the height of the lettering should be follow these rules. Like if you're using A4 sheet, just common original paper A4, the small paper. So you need to have a minimum height 5. Okay, so 5 millimeters should be the character height should be 5. If you have A0, A1, A2, and A3 sheet size, so then the minimum character height should be 7. Okay, so similar rules. Okay, so we have to follow the rules for the lettering, for drawing the lines, and for the dimensioning. Okay, so drawing a dimensions also we have to follow the rules. The title block. All design documentations should have title block. Okay, so title block is like this thing. So in the corner can have this kind of rectangle, and that rectangle, why we need this one? Because that rectangle includes the part name and who did this one. Okay, so designers or who is drawn this one, draftsman's name, and the part name and part number. Okay, so this document number. Okay, so this document number and the date, and who is approved this document, this drawing. Okay, and the company name and scale and weight of this part. Okay, so those kind of information, to include those informations, we need kind of title block. And here you can see the locations, how to manage the title block in different papers. So in A4 it should be like this. Okay, so paper should be vertically inserted. Okay, so vertically positioned, and title block should be like this. Okay, so in small side it should be drawn on the small side. In A3 sheet you can draw or A3 or bigger A2, A1, A0. You can do in both ways. Okay, in portrait mode or vertically can do both modes. It's okay. But in case of A4 sheet, so you need to do only this kind of positioning. Okay, so it should be on the small side of the paper. Okay, so so here you can find the title block sizes. So this is from the GOST standard, title block from the GOST standard. Okay, so you need to follow these dimensioning rules.
In this video, we are going to learn about engineering documentation. We are going to look at why engineering documentation is important. We will see what the term technical product documentation means, and then we are going to look into different types of documents you could encounter as a mechanical design engineer. Developing the product can be a long, complex, and exhausting process. There is more to the product development than meets the eye. In order to make sure that the mechanical design engineer, or any engineer for that matter, covers all the areas of the product design, different documents need to be created. We need to create part drawing for the manufacturing of single components. We need assembly drawings to fit different components together, calculate critical components of the product, test them, and ensure that the quality is satisfactory. Doing all these things without a plan and a clear understanding of what needs to be done is bad engineering praxis. The product development process involves groups of different teams working together to bring the right product to the customers. At the center of any product development are customers. There are many different requirements that customers expect from the product they are buying. Still, in general, the bare minimum is that the product fulfills the intended purpose, solving the customer's problem, and that using the device is safe for the customer. Using the product will not harm the customer. Let us say that the customer wants to buy a desk lamp. The primary function of the desk lamp is to convert one type of energy to illumination. Let us assume that our customer does not want to have any flammable liquid in their house and would want to use electric energy to produce illumination. Basically, what our customer, at a bare minimum, is expecting is that when they plug the desk lamp into the electrical outlet that it will lighten up the room, and that in the process of doing so, it will not electrocute them, kill them, or burn down their house. I as a customer appreciate when my desk lamp is not trying to kill me. Now imagine that the customer wants to have a light switch so they don't have to plug and unplug the cable whenever they need the light. On average, let's say that customers will press the switch 10 times a day. They're expecting to use the desk lamp for at least 2 years. So, you must make sure that your switch, on average, can be actuated 7,000 times without failure. Moving forward, your customers could have color preferences, shape preferences, additional functions like adjustable height, etc. The list of requirements could go in infinity. In order to develop and introduce a sellable product, all of the main requirements should be met and adequately addressed. Without proper systems and document management, this is hard to do. For mechanical design engineers, this means that the proper line of communication should be in place. Technology has progressed to a level that was just 20 years ago unimaginable. The products have become more complex and robust, the design is more demanding and complicated, pushing the limits of manufacturing technologies. Communication only with the engineering drawings is no longer enough. Mechanical engineering covers a wide area of different fields with various diverse technologies. For engineers to communicate complex sets of information acceptably and understandably, ISO has defined all the relevant documents for the specification of products, equipment, and plants. It is called technical product documentation. The technical product documentation types are defined with ISO 2984-5-2011. According to ISO 2984-5-2011, a document is a fixed and structured amount of information that can be managed and interchanged as a unit between users and systems, and documentation is a collection of the documents related to a given subject. While ISO 2984-5-2011 lists the whole range of technical product documents, we will list the most interesting for design engineers. Let's now look into different types of engineering documents. The part drawing is defined as the drawing depicting a single part that cannot be further disassembled and includes all the necessary information required for the definition of the part. In the part drawing, everything required to manufacture the single part is defined. Example, the form, dimensions, tolerances, material, finishes, treatments, etc. The assembly drawing is defined as a drawing representing the relative position and/or shape of a group of assembled parts. The assembly drawing is not showing the manufacturing details of a single part but merely how the individual parts are supposed to be assembled. The main assembly consists of sub-assemblies, parts, and materials. On the assembly drawing, we can include the part list, or it can be provided in a separate document. The parts list defines the list of the object's elements. The parts list is added directly to the drawing, or it can be provided with the assembly drawing as a separate list. The parts list shows only the top-level parts used to build the assembly. In addition, the parts list can be automatically extracted from the company's ERP or PDM system. With the part list, only one structural level is defined. The BOM is a list of the sub-assemblies, parts, and materials required for building the assembly. The BOM can be added directly to the drawing or provided with the assembly drawing as a separate list. The BOM shows all levels of components required to build the assembly. In addition, the BOM can be automatically extracted from the company's ERP or PDM system. The difference between the parts list and BOM is that the parts list defines only one structural level. The tabular drawing is defined as the drawing listing differing variations of a specific configuration using a single, common illustration. The shape of the component is always the same, but the relationship between different features is changing. In the table on the drawing, you can see that we have different values of the A, B, C, D, E, and T for the different configurations of the component. We could create a different drawing for each plate, but that is unnecessary additional work. The fabrication drawing is defined as the part drawing of an assembly of fully specified items permanently joined together. The components could be joined together by welding, soldering, or adhesive. Every component of the fabrication drawing should be fully specified. Also, the relationship between those components should be defined. The outline drawing gives the outside peripheral envelope, overall dimensions, and mass of an object. The supplier drawing defines a part developed and owned by an external supplier. Usually, the supplier drawings can be found on the supplier website, or you could contact the supplier to provide you with it. The illustration drawing shows figures and sketches for any general purpose not covered by the more specific document types. These could include figures for marketing purposes, figures for the instruction manuals or work instructions, etc. The document list is defined as a formally built-up inventory in which all relevant documents for a specific purpose are listed. This document can belong to a system, part, project, etc. The best practice is always to display the document identification number and revision of a document list and all documents listed in it. Other information depends on the company's preferences. The calculation sheet is defined as the document providing the results of calculations regarding essential product characteristics. This can include hand calculations, calculations according to the standard, FEA, CFD, etc. In addition to previously mentioned documents, we can also encounter requirement specification. The requirement specification is defined as the document compiled and evaluated with the requirements from the markets, customer, authorities, and the company itself. These requirements are usually stated in the form of wishes, and they are usually not measurable. For example, the product must be robust, strong, and waterproof. This type of document describes what needs to be built and not how. Technical specification. The technical specification is defined as the document specifying the requirements for one specific part or a group of parts with similar characteristics. The technical specifications are quantitative, and they can be verified. For example, requirement specification, the product must be light. Technical specification, the product's mass should be less than 3 kilograms, less than 3 kilograms. Part definition document. The part definition is defined as the text-based document that may be supplied with a drawing of the defined part, specifying property requirements for the part described by the document. This document is very useful if you have a procurement department. Defining the required technical data of the component supplied by an external supplier can be used for the procurement team to find a less expensive supplier without involving a design engineer or procuring the wrong component. Assembly instruction. The assembly instructions document is defined as a document providing information of how and in what sequence the different parts shall be assembled to receive a specific end product. Usually, for simple assemblies, the assembly drawing is used. The assembly instructions are created when the assembly process is complex, different tools and procedures are used. In that case, the assembly drawing shows the final assembly and the part list, and it is referring to the assembly instructions. The assembly instructions define the assembly process in great detail, with every step clearly and unambiguously explained. Test plan. The test plan is defined as a document describing the scope, realization, resources, and plans for the intended test activities. Test specification. The test specification document is defined as a specification explaining how to perform the test activities according to the test plan. Test report. The test report is defined as documentation of test results based on the tests carried out at a new part, assembly, product, or system. As you can see, there is more to product development than meets the eye. The mechanical design engineer is not responsible only for the design, but depending on the size and the structure of the company, the mechanical design engineer could be responsible for a whole range of different activities during the development phase. Creating CAD models and drawings in CAD software is the easy part. Knowing what to design and why is the hard part. Documenting everything is not because someone wants to give you more things to do. These documents ensure that all customer requests are defined, specified, understood, and translated to the physical product with satisfactory quality for the customer. Great quality products should have the same quality independently of the produced quantity. We want our first, 10th, and 1,000,000th customers to have the same experience with our product. Everything that you do is for your customer to be happy with the product and that they did not spend their valuable time and hard-earned money on a bad product.